Whoa, what a cool what's up everyone. I am excited to do some testing. Gonna be messing with lightweight transactions today. And be a lot of fun. I've already set up a cluster and I got some LWTs been running for a little while. I'm gonna just share my screen now. I'm trying out a new layout I set up here. So hopefully the issues of folks not being able to see the screen. See how this goes. So obviously I know that I'm taking up the upper right. You can't see it, but you know what? I don't really put anything useful up there the majority of the time anyway. So where is it? No. Code is over here, I guess. So we'll see how this goes. So just looking at this test. This is a 5.0 cluster, and this is using the head of 5.0. This isn't as of like a day or two ago. This isn't the beta. There's been a whole bunch of changes committed along the way, and I like to test the most recent stuff. I have been working on a handful of performance-related improvements. I'm trying to get some interesting stuff in. I found that I ran a test the other day, and as my cluster got overloaded, I noticed that 25% actually spent with these early tickets and get rid of all of it. So it looks like basically absolutely every hour, it's 50% reduction as a result of using. And the reason why this is a big deal, the reason why I care is because when hinting, the clusters kind of avoid capacity. So like basically that's why I really is because we hopefully get the current clusters to recover faster or won't be in a situation. There's a lot of stress put on node and there's a lot of hits happening. And adding more hope over it. Something so anyway, I'm just going to throw a little banner here, but I want to keep track of how so I'm doing. I was sharing a whole screen for the arrow. Try to share. I don't see everything, but you can read everything a lot easier. So maybe that's better. Okay, so this is what's going on with the case. So this is actually pretty much stock. I have a so this is the YAML the patch that I'm using. So in CastLab, the tool that I use that I've written, it has instead of trying to build out like puppet solve just call it. So this basically you can write a patch file. The patch file is a file on top of the reason why this is cool is because you really have to see what's changed. So you can see here four tokens, per pizza, triple on. Other than that, so it's pretty easy to see that one right now, like, have a test running doing this is really fluctuating performance wise. So up here it was getting like 100 milliseconds, 99 latency, and it goes to like 97, 48, 122. This is all over the place. Sometimes this can be the result of GC. So just looking here, this is you're not using H stop. It's a nice improvement. And, it's nice to I can just preview, see what's going on at the different level. There's one, actually not very old. What I'm going to do is take a quick look at these. Yeah, so we're supposed to one first thing that I like to do with nowadays, I don't really bother. I've got like a tool that I do part of this. I'll be honest, I really do it. It's not such a, it's such a pointless exercise. My preference now is so first thing to do is oh, there we go. Oh, right. This is, okay. But I'm going to use it. I'm going to use it. And like that's not what I experiment with. So that's a good idea. I like setting the unlock the options at 5%. Is this? Hmm, should be okay. It might be. Um, oh no, could be because it's far away. Okay. Hmm. Can you hear me now? Oh, oh no. Now due to the lag, I can't tell which one's better. I don't know if this is better or if the other one was better. Yeah, let's try this. Let's see how this goes. This is my this is my actually trying my headphones here, which is kind of a weird trying my Beats, whatever. Okay. Well, we're gonna go along. And so I've got the G1 settings here. So I'm just gonna roll these out. What's really cool about this is that it's pretty straightforward to build labs using Easy Cas Lab. I mean, that's what it's for. Um, but if I do this update config, watch this. You see. So update config. So this goes ahead. This patches the YAML. This uploads the JVM options, and then I'm just going to go ahead and restart it. I hope I fixed my restart script. So we're just going to try that out. Move this out of the way. All right, and then we can go Easy Cas Lab restart. Hands up, roller coaster. Let's see if it works. So over here, we'll just follow this. So hopefully we won't see like a big increase in the errors as my restart triggers, but looks like some stuff's erroring out. Oof, very non-graceful restart. I need to work on that script, but it's okay. It's a lab environment. Who cares? All right. Oof, always fails. Okay, that's fine. That's fine. Ignore that silliness. All right, so we should be okay. Cool. Let's see what we got here. So looking at the Cassandra startup, we now see that my max region or my max tenuring threshold is set, and there's my new size percent. So cool. That's on that node. Let's just make sure that it's on the other one. Will this work? I don't even know if this will work right. Cool. There we go. Cool. Okay, so I've got it. I've got the GC stuff. So now my system is trucking along again. Interesting. You're using tokens equals 4. Yeah. I mean, I don't know if you're baiting me, but I'll talk about that for a sec. So, yeah, Cassandra YAML ships with num token 16. And this was kind of like the result of a lot of back and forth in the community. Some folks like the idea of being able to shrink a cluster. I don't really see many use cases where people actually shrink clusters. And the thing is that if you have fewer tokens and you shrink a cluster, you've more of a risk of imbalance happening. So 16 is in place to deal with imbalance. But it from a performance perspective and from a stability perspective, I would not use 4, or I would not use 16. I think 16 is 256 is a terrible setting, like terrible. You do not want to use 256 tokens. It makes a lot of things more complicated and just awful. So just don't do it. Use 4 is the best setting, as long as you're setting allocate tokens for RF, or in older versions allocate tokens for key space. You definitely do not want to have a lot of tokens. There's no advantage to it. There's only disadvantages. It makes repair more obnoxious. It makes it less likely that you're going to be able to use zero copy streaming. Maybe you can't expand as fast. It means that you are a peer with more with more nodes. So if you take your replication factor, subtract 1 from that, multiply that by 2. So for RF3, it's -1, 2 times 2 is 4, times tokens. That's how many nodes your node is going to appear with. It's going to share data with that many nodes. So the more nodes you appear with, the higher likelihood the higher likelihood it is that you're going to have downtime if like any two nodes in different AZs go down if you're operating at quorum. So it kind of sucks that if you have this 90 node cluster and you're using um, 16 tokens, then that's 4 times 16, 64, but you only have 30 nodes in a 90 node cluster. You only have 30 nodes in each AZ if you have three AZs. So you basically a peer with each node in one AZ as a peer with every single node in the other AZs or up to. And the reason why that sucks is if you try and do a restart, it's like you can only have one node down per like at a time in your whole cluster or in across the availability zones, and that's just dumb. And so when you use 4, the math works out a lot better. Then it's 2 times 2 is 4, times 4 for the number of tokens is 16. So now you're paired with way fewer nodes. So if you have 2 nodes go down in different AZs, you don't have downtime for part of your cluster. Like it's just crazy. And so the fewer nodes you can get away with, the better. I'm actually kind of wondering if you could do 2 or 3, and I may just set that up. But anyway, it's an easy to configure change. If you didn't want to do it, you could try it. Anyway, back to my lightweight transactions. So this, you can see here, like these were a little less stable. Like times were kind of all over the place. Like earlier, it was like jumping into the hundreds. Now it's a little bit better. Not quite what I want to see. And we're just going to keep going here. So one of the interesting changes that has been done that I wanted to test today is was in what's it called? Cassandra 4.1. There's actually two changes that I'm two things I'm going to test today. One, I'm going to show you how changing because there's not a lot of data. Typically when you have a lightweight transaction, it's around something like an email, right? There's a handful of bytes, but it's not big. And so like when we go to a node, so I'll just jump on one of these right here. If I use a tool called let's see, file top. Oops. Oh, let's see if this works. I don't know why this is. Oh, there it goes. Okay. I wonder if it's caching the thread names because that shouldn't say mutation stage. It's a little weird that it says mutation stage. Anyway, shouldn't be mutations reading. Oh, stupid. There is. So lightweight transactions. Yes. Okay. Lightweight transactions do a read before a write. So one of the things that's interesting about them is that so if we do TP stats, so it's a mutation, but it actually does a read before a write.
so it can be, it's like tricky to tune if you don't realize it. And the reason why it matters is because when we start, oof, let's try this. Okay. What's going on here? Yeah, we're hardly hitting disk at all. Let's just take a quick flame graph and get a little performance base number. All right, so this command right here, ASProf, is the async profiler. I talk about it way too much. And this is going to give us a nice little profile. Oh. Yeah, there we go. Okay. So one of the things that's really cool with the lab tool, so I'm in this directory. I'll just show this real quick. So I'm in this directory here, and this is like the state. So basically, this is my lab environment. It's this, everything is in this directory. You don't have to go anywhere else. The patch file, the environment, the JVM options. This sets up the instance, the SSH config, and the Terraform configuration. So the SSH config is really cool because when you do source.env.sh, it actually sets up a bunch of aliases. So now I can do like, which I always type C0, but this is actually alias to SSH Cassandra 0, and Cassandra 0 is actually is set up in here as a host. So I'm essentially like, for this session, kind of having like a custom, I have a custom SSH config, which is awesome because it lets me just do that. Oops. Anyway, and then I can do the same thing with SFTP. So this is done. I grabbed from here, and one of the reasons why I like this kind of environment is like all of my files that I care about, because they're in this directory, I just download stuff to them, right? And so when I'm done, like I have a directory that has all the configuration that I use, the JVM parameters that I used, the flame graphs are all here. It's just generally really convenient for me to work with. So okay, so I'm just going to share something different so that you can see what I'm looking at here. Let's go with this. Okay. Okay, so now I have my CPU profile. The reason why I was looking at this is because whenever I do tuning, I like to look at my flame graphs. Like here, you can see like Paxos says Paxos v1, do prepare. You can see like that there's stuff going on at the TCP side of things. These are TCP messages. You go over here, you can see that like we're fetching rows. So I was basically just curious to see if we had any time that was being spent in LZ4 decompression. But it's not a lot. It's actually not a lot at all. So usually end up with a lot. But this is actually uh, the reason why it's not going to matter so much on this. Let me share my screen again. The reason why it's not going to matter right now is because we changed the compression chunk length to 16. So 64, crazy read amplification. 16, not so bad. And the reason why 16 isn't going to be so bad is because, let's see. I'll tell you in just a sec. Okay, so everything goes into easy cast stress LWT. Okay. We are seeing pretty good SS stable compression ratio. So this is 16K times 0.37. 5.92. So we're actually getting pretty good compression rate. So from an IO perspective, we're barely doing more than a page. So there's really not going to be a huge difference between fetching, like using this and like going smaller to like a chunk length of 8. It'll be a little bit better, but not by enough that I'm super concerned about it. So instead, what we're going to do is we're going to move on. So I took a look at the thing that I want to do now is see what happens when we roll out Paxos V2. Because Paxos V2 showed up in Cassandra 4.1. And if you're not using it yet, the whole reason why I'm doing this is to just get a rough idea of sort of what it looks like when we actually roll it out. So I'm just going to go and I'm going to grab this first. I'm going to save this for my notes here. All right. Oh, lame. What are you doing? What is taking so long? So if I run proxy histograms, one of the interesting things, yeah, see. Okay. So it's interesting that we're getting kind of like crap numbers out of here. I need to take a look at the driver. I wonder if I think the driver might actually not be sending enough concurrent queries. I could fire up more threads. But since this is like bouncing around pretty high, wait. Did I not give? Oh, I think I didn't give the bigger heap. I didn't give the bigger heap. That's what I did. That's why. Let's try that. Yeah, see, I didn't set the heap. That was silly. All right, so let's just grab that. I gotta set the heap. God, because right now it's using, before I change it, let's just see what it's using. I mean, I think it's actually only using the 8 gigs or something. Or like maybe 16. 8. Oh, that's why it's doing so bad. Okay. All right. So let's just go ahead and since I've got my JVM options in here now. Um, let's just roll it out. You may be wondering why I always type M by accident instead of a dash. It's because I'm using an Ergodox keyboard, which is stupid loud. And whoops, I think I just actually uploaded the wrong thing. Is it the wrong thing? No, yeah, I did set up. I want upload config. And I have it so that instead of having to like reach to type a dash, I type an M and hold it, but I don't hold it long enough. I need to actually make it so it triggers faster. Okay, so now we can do a restart. So maybe this will work. I don't know. It's important to have a reasonable baseline present before you just start mucking around. Although it could be useful to just see how the setting behaves on its own. Might actually just reduce GC overhead. I could take a allocation flame graph to check, but I'm actually really trying to like, oh yeah, look at all that. Come on. Yeah, do better. All right. All right, where's my settings? There we go. Cool. Okay, so it looks like my rolling restart works. Awesome. Even though it violently errors out. Oof. So while this is restarting, this is a very, very crude restart. It restarts, waits for node tool, doesn't give a break between nodes. It doesn't wait for anything to settle. It just really is meant to roll things out as quickly as possible without any regard. This is not for production. This is like it's for me to mess around with. And you can see the error count went up. So let's just give it a sec. We should see a reduction here as whoops. We'll leave that running. Okay. I guess I could also give it like a shorter JVM pause time. Could have also tried ZGC just to try to see what happens when we eliminate pauses, but this is starting to behave closer to what I expect. So I have a feeling that some of this stuff is actually getting served straight out of the chunk cache. Oh no, chunk cache is disabled. Yeah, I think we actually have it disabled right now. Oof, look at that garbage. Look at that garbage key cache hit rate. That's terrible. 0.2? Come on. We should make that bigger. All right. So I'm just going to go ahead. I'm just going to try Paxos V2 because That's the thing I'm the most interested in right now. That's the biggest change. So let's just go ahead and jump right into that. So for that, I have to do this. Let's just try. So I put this in here. Now, I haven't done this before, so let's just see what happens. Update config. Okay, so it's patching everything now. Cool. Okay. So it's patched everything. Now I'll restart again. Rolling restart. We'll see what happens. Maybe it'll break. Who knows? But look at that. It was doing a lot better once it calmed down from that craziness. The latency had definitely dropped quite a bit. So I'm just going to go ahead and save that. Well, good general rule, if you're going to run, oh, and I forgot one thing. Oh, maybe I'll do it next. I'm going to change the mem table heap space. So G1 is, I really don't see a reason at this point to use anything other than G1. Everything else has too many drawbacks. G1 basically just works. You don't have to deal with a lot of headaches. However, you do want to give it a fairly large heap. So, like, oof, look at that. As this node recovers, and our errors jump a little. So you want to give it a bigger heap. So I'll go with a 30 gig heap. And I generally also set my mem table heap space. So the reason why you want to do that is because if you have like a really big, if you have a really big mem table heap space, it just takes up like a ton of, by definition, space. And if you don't set it explicitly, then it uses a quarter of your heap. So right now I have like up to 7 gigs is going to be mem tables. That's a lot of copying. So I'm trying to, by using 2 gigs, I like to keep things out of the old gen as much as possible. So I'm essentially kind of treating Cassandra as like, my goal is to not have any long-lived objects. Like anything that goes into the old gen, I want to stay there. The reason why I use 4 on the what's it called, max tenuring threshold is because I want to keep objects bouncing around the old gen. I could visualize this, and I might do that after and just grab like a GC visualization. That's been helpful in the past. I really like using GC Easy. I'm not affiliated with them. I'm just plugging them because I love GC Easy. Tool is awesome. Right, so this is restarted. These numbers were obviously wild there. They're coming down. Let's just take a quick look. And so as this hopefully gets better, we'll see what's going on with HTOP. So the thing that I was curious about was what the change in network traffic is going to be. There might not be any. It might be the same. Just doing a quick look at MP stat. Curious if my CPU metrics have slowed down. I really need to get some dashboards in place for this so that I can look at the dashboards and go back in time. As I've mentioned a couple times, like I've partnered with the folks at Axon Ops for a couple things, but the major one is they're providing the tooling for my training that starts in like just under 2 weeks, 12 days. So yeah, so hopefully they get 5.0 support. I can start showing dashboards, start using dashboards. But for now, I got to rely on my command line tools. All right. So now, whoa, look at that. Oh my God, that is amazing. Seeing that down into single digit latency, that is amazing. Oh wow. Okay, if you're not on uh Cassandra 4.1, um and you're using lightweight transactions, like this alone might be a reason to upgrade. Just seeing these numbers right here get way better into 5 and 6 milliseconds, like that is awesome. And then I'm just curious if, I mean, this is really good. I mean, from up here when I first got started and it was like bouncing around between 80, 100, like whatever, like it never really went quick. And this here, where we're seeing like the numbers once they jump down, um, and all of a sudden now our writes are in the 12, 9. I mean, it jumped up to 30 here, but these numbers are amazing. 20s jumped up once, 60. The other thing is that this tool has GC pauses as well. So I might actually make some changes to Easy Cast Stress to use ZGC and just say screw it. Like you need to use Java 17, and uh, and if you do, then we can get almost no pauses here, because this is like, oh my God, I'm so excited about that. I'm not excited about that. Trying to jump up. What are you doing? Why are you jumping? Okay, and then this is all of a sudden. So, oh, you know what? One thing that I should probably have made a note of. Easy cast stress. You know, I created this with default options. So this is using size tiered. It might not matter. So we're just going to check node tool, table histograms. I forget if I can do that. Okay. Yeah, it's not going to make a difference. Yep. Bye, Victor. All right, so what do we see here? We see sometimes wild fluctuations, sometimes great perf. Not sure if it's the stress tool. Could be the stress tool going through GC. No, that wasn't even, no. That's old. What's going on here? A lot to do. Okay, so changing this to, God, I hate that. I hate that setting. So, yeah, we definitely see an advantage. Now let's just go ahead and grab a flame graph. Okay, sudo asprof flame graph. Let's go. Oops. I'll just do that. Oh, right. So gathering a flame graph. I can bring the two, I'll probably just bring the two up, and then that way I can take a look at the advantage and kind of compare the profile information. Yeah. Come on. So a little background. I mean, I talked a little bit about Paxos V2. The thing that's really interesting about it, Paxos, the original Paxos implementation, the first implementation of Paxos in Cassandra, would do up to would do 4 round trips. And the original Paxos paper didn't call for that. The original Paxos paper actually, like, you could do it in 2 trips. So we just sort of had this like weird unoptimized thing going on. And oops. Oh, no, get out of there. There we go. And the new implementation brings it down to 2 round trips. And the round trips are expensive, like time wise, like going to another node 4 times. And it's not like it's 4 times like, like asynchronously, even though that would be bizarre. It's 4 times, and they have to happen in order. There are dependencies. So it's just expensive to do that. Like twice as many round trips, obviously, is not great. So I'm not surprised to see a reduction in CPU activity. I'm not surprised to see things sometimes are faster. I'm a little bummed to see that the performance is sort of bouncing around a little bit, and I'm curious as to why. I'm also just going to go ahead and chuck my GC logs into GC Easy. Let's see. Okay. Let's go ahead and open this up. Oops. All right. So let me bring this up. This is Paxos V2. One of the things that's actually really helpful, I'm just going to trigger this in the background. So if you just give me 2 seconds, actually, I'll just, yeah, just give me 1 second. I'm just going to trigger a flame graph, but I'm going to do it in reverse. Okay. So while that's running, I'm just going to look at this. So the bulk of our time is spent in here, which I suppose makes sense. Let's see what this is. So this is breaking this down. This looks like we're seeing time in response verb handler. 2%, 10 there, 3 there, 5 there, 4 there. So the bulk of the time is here. So we can do a single partition read command. What is this? What does it say? So nothing is jumping out at me. Although, what's in here? So within Cassandra, this is only taking up like 1% of CPU time. It's not particularly like amazing. Oops. And now I'll just go ahead and grab this is a reverse flame graph. Let me take my face off the screen so you can see the whole thing. Reverse flame graphs are pretty cool because they are upside down. But they start at the top of the stack. Instead of starting at like all where the program is running and then building up in the stack, it does it from the thing that's actually being called. So in this case, like the thing that's interesting to me is seeing this right here. This is like a whole thing. So LZ4 taking up 3%, raw, spin unlock, Futex wait. This thing is, yeah. So 10% of the time is spent in this like parking threads. I don't love that. What's this? So this is actually looking pretty good. Hardly any time is spent in here. All right. So there's no obvious like wins or losses or anything like that. But I do want to, I am going to spend a little bit of time on this. This is kind of not my favorite thing. Yeah, look at that, 1,400 samples. So this is just from this is waiting park nanos. That's funny. Yeah, we might want to switch to a different threading model. I don't love seeing that just parking threads is like 10% of the CPU. Okay, so oh well, here we are. Okay, so the performance is back to where we want it. So this could definitely be, there could be a few things going on here. So because we're sort of seeing like perf numbers sometimes get better and sometimes get worse. It could be a result of compaction. It'd be really, again, I definitely am gonna have to accelerate my um, dashboards. We have now that we're using HTOP over here, I can actually see like which threads are doing what. And let's see. Yeah, so all these down here is where you see like mutation, request response. So what I could do would be to like look at only could ignore certain code paths in the configs or in the flame graphs, but I don't know. Okay, so basically what we have here is demonstrably better performance a significant amount of the time. Sometimes it jumps up inexplicably, but that doesn't seem to be any worse than what I previously had running. So just a heads up on the stress test. This is a lightweight transaction stress test built into EasyCast Stress. EasyCast Stress is my fork and rebrand of TLP Stress, the tool I originally wrote while I was in the last pickle for doing Cassandra benchmarking. I am honestly celebrating this. This is a huge victory. Oh wait, I'm I'm not on the right thing. There we go. Back. Okay. I consider this to be a fairly huge win. I'm going to save this. So yeah, I mean, I think that we have here is a notable improvement in performance. A nice test to do would probably be to set up 2 clusters and see what happens on both of them. That could be useful. But I'm probably not going to be going any further into that. I'm definitely going to want to see what's going on here, why these numbers are bouncing around so much. So let's just grab a flame graph. Because right now these numbers are kind of wild, right? And then so sometimes CPU gets really high. Not seeing anything blocked, fortunately. One thing to keep in mind is that one of the things that makes lightweight transactions tricky is that because they involve coordination between multiple nodes and multiple round trips, they are more susceptible to GC pauses. I'm actually gonna do my GC test now before I wrap this up. Let's just see what this looks like. So there are some like useful tools that you can do with locally. Like there's like a JVM GC Viewer, I think it's called. But I am pretty much in love with GC Easy, so they do a really awesome job. They come through. They really do. GC log. So I'll switch to that. Let's see. All right. 99% throughput. That's right. That's what you want to see. And then we've got these pauses. And oh, I hate long pauses. They're so annoying. Could try doing a shorter pause time. I love how the recommendation yeah, that's a good suggestion. Concurrent GC threads. Yep, that's good advice. G1 reserve percent. Yeah. Good advice. This is what I want. Yeah, the 300 millisecond GC pause times are like so annoying when you have a lightweight transaction cluster. So that would definitely explain why I'm seeing like huge variance in these numbers sometimes if there's like a long pause. So all right. Cool. Okay. I'm actually gonna I'm just gonna try a couple things now. I'm gonna increase concurrent GC threads. So these boxes have like eight cores. So let's just I mean this is past this is actually past what I was planning on testing because doing the GC oops. Whoa, no, not what I wanted. Yeah, give me concurrent GC threads. Let's just try, oops. So I think, let's just see what happens when I do 8. I don't think that this is actually set. Ensure Paxos repairs are running regularly takes 1 round trip. I'm not sure what you mean by that. Ensure Paxos. I'm not sure what you're trying to say here. Let's see. There we go. So I'm probably I'm gonna try one. I'm gonna lower this. This I don't think that you can make this lower than 200. At least you couldn't in previous JVMs. let's see. I would love it if we could, though. I'd love to see that like lower, but I don't think it's going to help. Oops. Am I already doing this? Yeah. All right. Oh. I forget the new format. Let's just check here. Got to make this easier to get to. That's the one. All right. Need to build a rolling restart into this command. All right. All right, now let's roll this out. What else was I going to do? Nothing else. We're good. Restart. Whatever. Oh man, I was going to reduce the pause time. Whatever. Once it's done, I'll, oops. Just do it here. I don't think it will even. I don't think it will actually honor it if I go less than. Oops. Where was it? There we go. Let's just. Yes. That is. Oh. Oh. Okay. News.text says, is sure Paxos occurs on irregularly, is probably on a separate schedule, set stat purging, allocations may be saved and updated. To use any commit consistency level, contender. Yes. Yeah, the whole Paxos repair thing. I mean, I'm not running that now. I don't really care about it. But in a regular environment, you definitely would. Um, you know what? I just want to see what happens if I just like. I don't think it's gonna. I don't think it's gonna like it. Yeah. So this is really the big thing. This is uh this is where the performance improvement comes from. Um, and basically what it is, it's combining two of the phases together. So it used to be the four, and then now it's I forget the exact terminology for each of the phases of the previous one, because it's like prepare. There's prepare, read, propose, and commit. I think were the four, or there might have even been another one. I don't have Paxos in my head right now. All right, so let's see. Easy cast lab restart. Let's go. Who cares? Get rid of this. Restarting. Everything gets terrible. Um, I'm sure that this is going to be like, no, you cannot. I'm going to let this run for a minute here, and hopefully this settles back down. Although, let's just get a regular flame graph again. So I'm building. Um, I'm going to be building some tooling into this so that I can capture flame graphs from all the nodes at once, or just have it run continuously. There's a really interesting project called Flamescope. I'm just going to deviate here for a minute. Share this. This is pretty cool. Um, is it this one? So this is a really cool project. I've used this before. I used this back when I was at Netflix. I really, really like this. Um, here's a good overview. I'll just drop this in the chat. Flamescope's pretty cool. So basically, what you've got here is the ability to do like um, sub-second heat maps, and you can like drill into individual moments of time to figure out what was going on. So instead of viewing this like huge aggregate of like 30 seconds or a minute, you can go right into like a second window or 2 second window or whatever. Um, so, oops, I don't know why. I don't know what the deal is with these screenshots. um, but they're pretty cool. Um, So next week, I'm not sure what I'm going to be doing exactly, although I am tempted to switch it up. I've been talking about this stuff. I've been doing Cassandra Performance live streaming for a few weeks now, um, and kind of looking at it. But I think there's some other topics I'm kind of interested in talking about. So I'm really thinking about taking a look, sharing some information about Open Telemetry, which is an interesting project. I gave a talk at Scale 21X, the SoCal Linux Expo, on Sunday, so 3 days ago, and I was talking a lot about Open Telemetry, and people seem really into it. So I think I'm gonna uh, ex- go over that stuff again. If folks are interested in kind of seeing that, leave a comment or something so I know, because or even if you're interested, if you have a topic that you're interested in learning about, um, right now oops, these working sessions, I'm doing them this way because I'm doing this stuff anyway. Like, I enjoy this, so I want to share this because I like it. Um, but if there's a million topics that I can talk about. So if there's something like that's either performance related or database question or something like that, just drop in the channel. If it's Cassandra, there's a decent chance I'm gonna have some clue. But if it's a different topic and I don't know it, like if you ask me to talk to you about MongoDB, like I don't know enough about the internals of Mongo, and it's been over 10 years since I did any serious work with it. So I'm pretty sure in the last decade they've made a couple changes. Um, all right. So now we're sitting here and our times are back to where we want to see them. So the question is, can I now use GC Easy? Watch, I'll probably be out of uh my monthly quota. What I do know is that these times are great. I'm convinced that this is a strict improvement, at least performance wise. Um, let's see. Where am I? Oh, and then grab this one. Get okay. See if that works. It looks it. Oh, nope. Look at that. Garbage chat pauses. All right. So the question is, um, could ZGC help with this? All right. One last test. That's it. One last test, and then I'm wrapping it up for the day. One last test. I'm going to try this with ZGC. I don't know if I'm going to configure it correctly because last time I tried to do this, I did not. I did it wrong. But to me, it should be interesting to try and see how it goes. So I think that most of these things go away. We're gonna leave the heap. I mean, I might as well leave experimental VM options on. I'm gonna leave my 30 gig heap, and then let's just go with, I'm pretty sure I have this stuff saved. And okay, so I think it's just that. I think it's just this ZGC option. All right, and then apparently you can set the concurrent GC threads, and it claims to be able to do that by default. So we'll just see what it does with that. I don't know. So we know that we're seeing kind of some like longer pauses, things jump up. And it could also be related, like I said, to pauses in EasyCast stress. So I'm going to try updating that. I'm going to double check that and see if it's experiencing pauses. I could just attach to a JStat and get those numbers. For this one, since I'm not sure if it's going to do it right, there's actually a script on here. Okay, so now it's done. Let's see if this works. I love this I love this system that I have. This is just like the most fun thing for me. It's like everything just kind of like it's super hacky. I think that might be why I like it. There's no, I don't need to like learn Puppet like or some other tool. It's like it's just, how did I feel like making this stuff work? Just go. It's a nice thing about just making a tool for myself. Um, so if this one works, I'll just have it do the other two. The really fun thing about this is that like I've been considering also making like a Slack bot, turning this lab tool into a Slack bot. So I could just give commands to it and tell it to like update a config, and then it'll just go ahead and run the update the config, restart the cluster. I don't know. I think it could be pretty fun. But you know, I like to just build stuff. All right, what are you doing? Waiting for Cassandra to be available. Probably an issue. Let's just. Uh, okay. Oh, it just took forever. Great. Cool. Yep. Ignore that. This is kind of crazy. The last time I did anything with ZGC, I found that it allocated memory so fast that um, Cassandra allocates memory so fast, the ZGC just wasn't keeping up, and then it fell behind. Didn't work out. No bueno. Okay. All right. So I've run. Did I restart on this? So I restarted 0. I thought I restarted Cassandra 1 somewhere. It doesn't look like I did. Oh, it was this. Okay, so I can run this again. So C2. Remember, C2, C0, C1, C2. These are just aliases. So this is an alias for SSH with pointing to my custom SSH config, which just configured for these nodes. And then this custom restart Cassandra and wait thing, all it does, this is actually quite a, I was actually working on this today, which is why it's not like working in a sane way. I'll show you on a different node, actually. Curious about how this works. So there's a restarting Cassandra can take a while because you typically want it to not just start back up, but to get back to like where it's serving requests and has served some number of requests before you go back into it. Um, and you want the latency numbers to come back down because as soon as everything's allocated, like the JVM is doing all sorts of stuff. And if you just restart all the nodes at once, then you kind of kill your performance. So like a lot of teams will just put like 5 minutes in between the thing so that you just have a rolling restart. And well, it's okay to do that. It can take longer or it might not take as long. Um, wow, look at that. I'm gonna let this go for a little bit. Is this I'm curious if this is gonna like tip over or if this is gonna be okay. Um, looking here, oops, why am I not on any of these? Zero. But looking here, basically the thing you want to look out for is for the ZGC workers to start taking up a ton of CPU. ZGC is also a little weird. So this was something that I got an email about from the first time I was testing ZGC. I got an email from um, hold on. From Bowen Song, who pointed out that even though it was using very little CPU, there was a good chance that the heap was just full and there was like a minimum number of threads trying to like unblock it, but it won't register as super active CPU time. So I was actually seeing low CPU, and you pointed out that it's a really good idea to just check individual threads. So that's why I set up HTOP this way. So HTOP can actually like this isn't the default view. So if you want to like use HTOP really well, You can go here to display options and set the tree view. And then you can also set show custom thread names. And the reason why that's nice is because you end up um, seeing the name of the actual processes within the JVM. So here it's pretty good. And then you go down. So it's doing some compilation, messaging and that. Yeah. Um, so this is a pretty interesting like look into ZGC. So ZGC for now is at least giving me more predictable numbers. Um, so the key to it might just be to use a really big heap and not push the nodes too hard, and then you can get low latency. But you can like it doesn't really solve like to me that I don't know. I don't know if it's really solving the same problem, especially since it fails spectacularly and like nothing works. So I'm not yet sold on it for this. I think Java 21 adds support for generational ZGC, and I think that's going to be a lot better from a performance perspective with Cassandra because we allocate so much. Because every time you read, you're bringing stuff into memory. Like it's it's tricky to have a like a perfect memory allocation model where you just don't generate garbage. So using ZGC, you know, is risky because if it can't keep up, everything basically gets full. G1 has a like has a mechanism to prevent that from happening. So I almost feel like ZGC needs to like prevent um it needs to have the same thing. Like, don't allow memory to like if it reaches 70%, just do a stop the world or do a pause um, and collect some regions. But like, it shouldn't wait until it runs out of memory in order to stop collecting. I think that's a bizarre decision. So here's what's really cool about this. So now uh, I'm seeing pretty consistent performance here. So this definitely seems like uh, we want I mean, this is nice. Like seeing really low pause times consistently is pretty sweet. So this is definitely um, giving a lot of promise. I think that I think this is amazing. Um, but the collector has to keep up. So if we ever see a spike, if things get crazy, if we run a heap for any reason, it's not looking too good. Let's do I, I think that this won't actually work. I think I need to connect to. I haven't done this in a while. Um, let's try. No, it doesn't like that. What does it like? It doesn't like that either. Oh, No, doesn't like that. What was it? Yeah, I can never remember how to use this. Probably just skip this for now. Remember it later. Hmm. All right. Well, I'm gonna wrap it up now. I think I got what I came for. Paxos V2 uh, definitely seems like it's been an improvement. Um, but I haven't tested it with default GC settings. So, this is why you need to do a lot of different rounds of testing. So I would want to see what this looks like using. Oh no, we did. I tested it with G1. This the all. I did not test Paxos V2 with. I didn't test Paxos V1 with ZGC. That's what I missed. But it is doing more stuff. So um, whatever. That's for another time. If you're interested in running these types of tests, check out my tool, Easy Cast Lab. And if you're interested in doing uh, this sort of stuff, learning how to do performance analysis and figure out what's going on, and you want to learn a bunch about Cassandra, I still have a couple spots open in my training that starts a week from Monday. Take a look. I'll drop a link in the description. And yeah, if you're interested in learning more, definitely check it out. All right, I'm going to head out. Have a good day, everyone. Thanks for dropping by.